Hello and welcome to another session in this series, Programming Daily. Today I'll be again working on my drakon-renderer. I figured there's no point delaying this further, so I think it would make sense to start working on the issue I reported, I guess, last week about slightly different approach to laying out the icons on the Cartesian plane. I gave it a little bit of thought, and I think I have an idea how to resolve this issue of this gap being here. Feel free to go through this issue if you don't remember. But it would involve some dramatic changes to the layout engine. So stick with me as I redo it or provide an alternative method of laying these out, and let's get to work. You'll probably notice that I'm cancelling a lot of work that I've done over the weekend. I've just been experimenting. So I have an idea for an algorithm that could potentially solve the problem of this gap being here. But first, I need to translate these icons into a 2D list that contains a list of levels, where each level is just an ordered list of icons. I tried various things with this function, and yes, potentially we could resolve the problem with just altering this, but I feel it's already getting very unwieldy and very complicated. I believe we can do something simpler, even if it means more lines of code. These two functions calling each other, it is clever, but I think this is as clever as we can go. Anything more added to the function signatures and to the logic will just make it pretty unwieldy. So let's kick it off in a very relaxed fashion, and let's just focus on translating the provided icons into a 2D plane. this function is very handy. It topologically sorts your graph, and then if you just do head, it selects the top icon, which in our case is the title. Oops, sorry. So it's supposed to be a 2D plane. So let's start slow. To that plane, we're adding the X. And this is going to be the only element in the first row. And in row number 2, we'll take a sneak peek how to get dependencies. Sorry. And also here we'll need an S, which in that previous function here is the entire list of icons, or the entire list of nodes containing icons as their payloads. Let's call it all icons. And this is going to be n still. Let's see this function signature. So I got the type wrong. Instead of an icon, it should be a graph node parameterized with an icon. And here, is this going to work? This is a one-dimensional array, or one-dimensional list. And this, is this a two-dimensional list? I think it is. Three. Oh, so this is expecting an entire graph. Oh. So I think this would be more appropriate, wouldn't it? Yes, and now this. Sorry, I copied the wrong thing. Oh, I'm still operating in terms of nodes, but you know what? That might be fine. Let's just change the icon to the type node of icon. For now, I don't need this to be perfect. I just want to run a relatively quick experiment to prove or disprove whether the new algorithm I have in my head would work. And the other algorithm is for positioning those icons provided in the input. Here we need to also give it all nodes. Let's change all icons to all nodes, which is more accurate. And also, we'll need to change the function signature of this function because it doesn't have, well, maybe it does. Where all nodes, and how do we get all nodes? Oh, basically topologically sorted nodes. And let's see the type of this. Oh, it's basically this. Beautiful. So here, I don't even have to use all nodes. I can just do topologically sorted nodes. And build. .25. So in this case, I don't need a payload. Sorry, so that would be this. Will it? Yes. And this would be probably a good moment to get rid of the directed graphs library to make the whole process of building my development environment faster and not to depend on an external library. So what I'm interested in is in calling this function and seeing the outcome. The only thing I need is a deserialized list of icons. Just icons after the validation. Oh, we can optimize this a bit and get the handle to the file only after we do get positioned icons. Meanwhile, here we can call this alternative Cartesian positioning, and we need to give it a graph. Hold on a second. What would be easier to print? A node or an icon? I think an icon would be way easier to present. Let's do this. Payload X. And this we can turn into a list comprehension where we'll be iterating through a collection of nodes and we'll be turning them into node. We'll be turning them into icons. I hope this is the right syntax. I can never remember the correct syntax for list comprehensions. So here in this function, we'll change the return type to just record.icon. I also need to export it. All right. And now I can simply do print, I think. All right, so what do we have here? I could use a program to pre-print lists or lists of lists, but that's fine. So what we need is a list of lists where every level is represented by the first dimension of the list. And it looks like this is not what's happening. It looks like level 1 already has 2 icons. Let's go back to the layout engine. It must be an incorrect way in which we construct this. Let's see if this works. Okay, this is level 1. No, it works the same way. Hold on. No, it is actually correct. What did I have here before? No, it is correct. I don't know what I was thinking. So this is a list of just one element, and this also is a list just of one element. That's good. All right. I think that's fine, and we'll wrap it up here, and we'll continue recursively calling this function on the next time, or maybe let's try doing it today. So we would need, so first of all, if we want a list of lists presented like this, level 1A, level 1B, sorry, level 1 can only have one element, level 2A, level 2B, etc. We need to come up with a reasonable data structure for this. And I think a reasonable data structure would be a dictionary. Where the key is the level identifier, say int, and the value is a list, or let's do it like this, of icons. And we would be passing this dictionary along the functions, or just one function, and we would have it recursively add items to it. But I think we can do it next time. Now we have a good idea how to, or what type to use. I'll need to do some digging as to what kind of Haskell type would be good for this. I'm not very used to working with dictionaries. I'll try to propose something for the next session. In the meantime, thanks for sticking with me. Just to recap, today I've been trying to get the code prepared to prove whether my idea for the next algorithm would be good or not. And the algorithm is going to be responsible for laying out these icons so that we don't leave this gap in the rendered product. It will probably take me a longer while to figure it out and implement the algorithm fully, but stick with me. In the meantime, thanks very much.